There you go. Yeah, instead of a gavel.
That's the gavel.
All right. Well, I want to thank everyone. That's a short belt.
That was my
maybe
stomach.
you want to switch with him.
We always switch.
All right. Well, tonight's a great night again. We're kicking off the lecture series for 2010, and as promised, they're all free this year. So that's really something that I'm really glad everybody turned out for.
Free? I thought you said
Oh no.
paying.
Oh yeah. Well, those of you who paid. But we're really excited this year. To start with Rich as our first lecture. It's 200 years in the anniversary of the company, and Rich has been doing a lot of history informally with us and formally through other institutions, and really has looked at the mill's history and has put it together in a paper that I have that you can get copies of after, and some of you I know have them. 200 years of rolling on the Brandywine, and you put it together for the Society of American Iron
Association of Iron and Steel Technology.
That's right. Yeah. So that'd be very good. And I guess it was this week that you had the presentation. So hopefully everybody really, learned something about how this mill started as a small entrepreneur, what it means a rolling mill, and some of you know, but it's interesting to hear the progression and the needs of the capacity and how they change. So without further ado, I want to give you Rich Smith. And Rich is the manager of product and process design. So, and I'm not sure, they always joke about how many PhDs you have as well. So.
None. I have 3 master's degrees. That's what they joke about.
That's nice. Well, thanks very much for coming tonight and speaking to us.
Okay.
Thanks, Rich.
Good evening. Thank you for coming. As Scott said, I've been looking at this for a long time from an engineering standpoint, trying to understand how things were done. I've worked in the rolling mills for a while. My mentor is here, Harold Swar. Harold, stand up. He taught me a lot about rolling. And he actually graduated high school with my mother, who's here also. And one time I was looking through her yearbook and I saw his picture, and that's how I knew. And we have Dave Rodriguez, who was in the rolling mill at Lukens for a long time. Dave, thanks for coming. And these guys are part of this history, a lot more than I am. I've been working at ArcelorMittal for 33 years, and it's interesting. As we go through here, I'll point out some things, but in high school, I was fortunate enough to participate in the Lukens Student Management Conference, which was one of the things that Lukens used to do to develop talent in the area. They brought us here for a week and brought in the accountants, the engineers, the salespeople, and taught us how the industry worked, which piqued our interest. And I went away to college, funded partly by the Lukens Scholarship, which paid about half of my college tuition. And I came back and worked 3 summers in the mill, and when I graduated, I came back as an engineer and worked in the mill. I've worked in various parts of the mill, and in the mid-'80s, I hooked up with Harold Swar, and we worked on lots of rolling projects. We used to head down to Conshohocken at 2 in the morning when they were working 10 at night to 6 in the morning. And once I got infected with a rolling bug, there was no getting away from it. The melt shop was neat, but things moved really slowly. In a rolling mill, things moved back and forth really fast, and it was really neat. And that's what piqued my interest. But in starting this research, I was interested in how they made iron 200 years ago, how they rolled iron, how they moved it around in the mill. So from an engineering perspective, I started to look at this, and this is the result of it. 200 years of rolling on a Brandywine, a celebration of innovation and survival. As you probably know, the plant of ArcelorMittal Coatesville has dominated the landscape in and around Coatesville for well over 100 years. Over the years, it has grown to 950 acres that straddle both sides of the historic Brandywine Creek. Today, we have 840 employees, and we roll almost 500,000 tons a year. At one time, there were hundreds of rolling mills in this country, most of them in eastern Pennsylvania. Today there are only 11 plate mills left in this country. I tell people that I grew up in the shadows of the Open Hearth over in West End. This picture was taken in 1960 and it shows Open Hearth's number 2 and number 3 close to the highway. and that circle is the house I grew up in. Now, if you drive by there today, that house is the only row house that isn't there. It has been knocked down. I don't know why, but my mother always said that we were going to bring the house down one day, and apparently we did. But today the process is much different. We start by recycling scrap in a melt shop in a 165-ton electric furnace. When it's liquid, we tap it in a spectacular event into a large pot called a ladle. We take it over to a refining station where we get the exact chemistry that we need for the customer. And if needed, we can degas it and remove detrimental gases in a tank degasser. We have to put that liquid steel in some form to move it around. For big, heavy, and wide plates, we use ingots. We're one of the few companies that still make ingots in this country. If we don't need a big, heavy cross-section, then we take it over to the strand caster, pour it into a bath-type-like device that goes through a machine and comes out in one continuous piece about 600 inches long. And we cut up that strand and get the weight that we need. Then we heat the ingot or the slab in one of 15 soaking pits to temperatures that make it soft enough to change the shape. That temperature is usually around 2300 degrees. And we roll it on either the 140-inch rolling mill or the 206-inch rolling mill. You may have seen our products being shipped out of the mill on either a truck or a rail car. We make a wide range of products. Some are very thin, some are very thick. Our products range in thickness from 3/16 to 28 inches, in widths from 48 to 195 inches, in lengths from 10 feet up to 100 feet, and they can weigh up to 60 tons. We also have unique flame cutting abilities that we have developed over the years, and with that we can make very unique shapes, like this 25-inch thick press platen that's going into a hydraulic press. Our products are used for a variety of applications. One is equipment for construction and mining industries. The picture on the right is a large drag line. It has a gigantic bucket. Actually, we have a division, or had a division, that used to make these buckets. Back in the 40s and 50s, a division called Lukens actually made and shipped these. These are pictures from Dewey Pile of a bucket being shipped. And ironically, these pictures are right past where I live today. That circle is where my house is now. And that spring house was originally a blacksmith shop. It has a spring in the bottom, and it has been traced back to 1765. Our products are fabricated into beams for bridges and also process vessels that are used in the oil, gas, and chemical industries. Our products also afford ballistic protection for surface ships and submarines, as well as land vehicles such as the Humvee, the MRAP, and the M1A1 Abrams tank. And this July, we are celebrating our 200th anniversary, a unique milestone that very few companies have ever attained. And to fully understand what this means, you really have to go back to the beginning. And the beginning begins with a man whose name was Isaac Penn. Isaac was the son of a very successful Quaker farmer. He was a farmer himself, and at one point he got the bug for the iron industry, sold his farm, and established the Federal Slitting Mill in 1793. That establishment was located 4 miles south of Coatesville on a little stream called the Buck Run. Isaac ran the Federal Slitting Mill for 17 years, and then he thought it was time to expand. So together with a partner named Jesse Kersey, they bought a farm from the man for whom Coatesville was eventually named, Moses Coates. That farm had a sawmill on the property. They used a water wheel from that to convert it into a rolling and slitting mill, which they named the Brandywine Ironworks and Nail Factory. And this location was much better than the first location that they had, or that Isaac had, because it was located at the intersection of the Philadelphia and Lancaster Turnpike, the first hard road built in America, and the Brandywine Creek. The Brandywine was much bigger than the Buck Run and supplied more power. There was also a village nearby that grew into the city of Coatesville, and that could supply manpower for the mill. There was also a mill dam existing from the sawmill that created a mill pond, and from the mill pond, water could be diverted in a head race and taken to the mill to turn the water wheel that powered the rolling mill. Transportation was very difficult back at that time period. The only way to move material was by horse, wagon, or pack mules, and most of the roads had just been Indian footpaths that were widened over the years. And if you've ever taken a walk in the woods, you know that roots, ruts, and things like that can cause issues walking. Well, it created the same problems for horses and mules. Making iron back then was a three-step process. The first step started with a blast furnace. A blast furnace was a 20 to 30 foot high stone structure with a shaft down the center and a hearth at the bottom. They were typically built into the side of a hill to make it easier to load the raw materials into the top. The raw materials included iron ore, charcoal for fuel, and limestone, which melted and created a flux to absorb the impurities. The charcoal couldn't get the fire intense enough to melt the iron ore, so they needed a blast of air. A water wheel was used to provide that through a reciprocating piston that pumped air into an accumulator and was fed into the blast furnace right above the hearth. When the ingredients were melted, the slag was tapped off onto the ground, and the cast iron was run out into the sand floor in the troughs. When the liquid iron filled the troughs, it is said that it looked like a mother pig feeding her babies, so it was called pig iron. The second step in the process involved forging the iron bar to remove more impurities. The early forges were no more than a large blacksmith shop with a hearth to heat the pig iron and a hammer and an anvil to beat the pig iron against. As the hammers grew larger in size, they needed water power to help lift the anvils. And that was generated by a water wheel. The water wheel turned the shaft. The shaft had a gear on it that had lobes. The lobes came around, caught the underside of the hammer, lifted it up. As the lobe moved away, the hammer fell. These hammers typically weighed about 500 pounds. At the heating temperatures, the impurities inside the iron were liquid, and hammering it squeezed it out much like you squeeze water out of a sponge. In the 1700s in Europe, they had drawings of forges, and they looked like this. They had a heating chamber attended by one person. Another person took the pigs over to the anvil and used a hammer to pound out the impurities, and he had a helper. And the third step was the rolling and slitting mill. In colonial America, they were powered by water wheels. They included a shear. The shear was used to cut the forged bars into manageable lengths. The lengths were put into a heating chamber or an oven-type device, and they included a rolling mill and a slitting mill. Now, if you look closely at the rolling mill, you'll see that there's no devices on top to adjust the screws, had no screws, so to get different reductions, the rolls were turned to different diameters. So you put the iron bar through the section of the roll that had the required opening that you need to get the reduction that you wanted. And then on the last pass, if you wanted to slit it into rods, you took it over to another mill that had cutters in it, and it slid it into rods. These mills hadn't changed since the early 1600s. They had rolling and slitting mills in Europe as early as the 1600s. They were operated by a water wheel that turned a shaft. Two water wheels were used, one to turn each roll, the top roll and the bottom roll, because they didn't have pinion gears that could reverse directions. So one shaft drove the top roll of both the rolling and slitting mill. The other water wheel turned a shaft that turned the opposite roll of both mills. By 1764, they looked, again, pretty similar. It had a heating chamber, a shaft from a water wheel, one on each side of the mill, a small narrow rolling mill, the iron bars from the forge were only about 4 to 6 inches wide, so the roll didn't have to be very wide. This one had adjustments on it, so they could move it up and down, and the mill was probably only about 8 or 12 inches wide, and then a slitting mill. And you can see they're passing the flat bar stock through the slitting mill, and a series of rods are coming out. One of the earliest mills recorded in this country was built in 1751 in Middleborough, Massachusetts. It was powered by 2 water wheels, and there are actually drawings of this mill available. It had 2 head races. One powered the water wheel on one side of the mill, one powered the water wheel on the other side. And even back then, Rod, they had problems with turn up and turn down. And to control that, they would adjust the gate in the head flume to change the speed of one of the water wheels to put a bias in one roll versus the other and try to roll it flat. A slitting mill looked much like the slitters that we have today, slitting sheet products. Now this one had a pinion stand, so it had one drive coming in and a pinion stand turned both, the top roll and the bottom roll. And the rolls were cut down to different diameters and had slots in them that had a small amount of engagement in, and when you put the flat stock between the top and bottom part of it, there was enough engagement that it slid it just like a rotary can opener works. Nail manufacturing was very important in colonial America because they couldn't get nails from Europe. It took too long, and everybody wanted to build a farm. They needed fences. They needed barns. So they took the wrought bar from the forge and rolled it down to flat stock. Some of that flat stock went for barrel hoops, wagon wheel bands, and general blacksmith use. The rest of it was slit into rods. And then the rods were distributed. Sometimes the mill made the nails themselves, but often farmers would take the nail rods, and in the evening when they had nothing to do, when it got dark at 5 o'clock in the winter, they would put one end into their fireplace and hammer the rods into nails using an anvil in their house. Hoops were used for barrels and buckets to hold the wooden staves together. Everything was shipped in barrels back then. They didn't have many containers. The wooden staves would be fitted together and held together with the barrel hoops. They also used the same type of hoops to hold wooden buckets together. If any of you have ever milked a cow in your younger days, you might have used a wooden bucket. We use stainless steel today, but back then everything was either a bucket or a barrel. And then the bands were also used to protect the outer surface of wooden wagon wheels from the hazards of the roads back then. The general blacksmith use included making brackets for something like this wagon to hold the sideboards together. I have an example of a T-hinge or a strap hinge that I found on my property. As I said, the spring house on my property has been traced back to 1765, and I found quite a few articles around the fields. I'll pass this around. You can see the square nails that were used. Iron was really soft. When I found that, it was pretty mangled. I took it down to the basement, and I thought, well, I can use the vise. Yes, I have a vise in my basement. It's the only vise I have. You can ask my wife. She probably won't agree. And I put it in there, and it was extremely easy to straighten out. I found I could do it with my hand because iron was so much softer than steel. I also have some nails that I found when my barn came down. I'm going to pass these around. Now, if you look closely, I want to see if anyone can pick up anything in those bags that may not belong there. What about that nail?
Number 6 common.
I put a regular nail in each bag to see if anyone would pick that up. Good job, Gene. You get a gold star. Now, Isaac Pennick and his partner, Kersey, ran the Brandywine Ironworks together for more than 6 years, and then Isaac bought out his partner and turned the business over to his daughter, Rebecca, and her husband, Dr. Charles Lukens. Dr. Lukens was a medical doctor that after he got married, got the bug for the iron industry and gave up his medical practice, moved to the Federal Slitting Mill, and him and Rebecca ran that mill as the doctor learned the iron industry. After a couple years running the Federal Slitting Mill, they moved to Coatesville around 1817 and took over the Brandywine Ironworks. And about that time, a new market was developing. Men were trying to develop better transportation between the larger cities using the rivers. People like Robert Fulton and Robert Livingston were trying to develop steamboats. Robert Fulton's Claremont was the first successful steamboat, and they were powered by steam boilers. Originally, copper plates were used for the boilers, but that proved to be too expensive, so they imported iron from England. Dr. Lukens saw this as an opportunity, so he modified his mill. And I think that means he took out the cut rolls and put in flat rolls and perhaps widened it to make a small plate. And in 1818, he produced the first boiler plate produced in this country. 7 years later, he had another milestone. He produced the first plates for the first iron-hulled ship built in this country. It was built by John Elgar in York, Pennsylvania, and it was called the Cordurus. The Cordurus is a small river that flows into the Susquehanna. And I know that because my father's from York, and he used to haul block from York, and the block plant was on the Cordurus. Now these plates were only 1/12 of an inch thick, 0.083 inches, which is really thin. And they were 23 to 25 inches wide. And the order back then specified that the plate should be free of buckles and bilges so as they would lay flat. So even 175 years ago, people were still complaining about flatness. Some things never change. We don't know exactly what the plate mill looks like back then because this was before cameras were invented, but the documentation indicates that the rolls are about 16 inches in diameter and between 3 and 4 foot long. The heated blooms or forged bars were cut into small lengths that weighed about 100 pounds, heated in an open fire on a grate with charcoal fire, and rolled to thicknesses of about 3/16 to 1/4 inch in 3 to 7 passes depending on the starting thickness. The starting thickness was typically 3/4 of an inch to about 3 inches, so they didn't have a lot of reduction. And an expanded view of that shows a person attending the furnace, a couple people passing the material back and forth through the mill, and a couple people cutting the plates to size on a shear driven by the water wheel with the lobe devices, again lifting the shear up and down. And just when things looked to be going very well, tragedy struck. Dr. Lukens died suddenly from a fever in June of 1825. They didn't have penicillin back then. Once you got something like that, you were at risk. And on his deathbed, he asked Rebecca to promise to carry on the business, and she did. And in doing so, she became the first female industrial leader in America. She ran the mill for over 20 years, and in 1834, she rebuilt the mill, expanding the width out to 48 inches. She also built a new dam which had a higher breast, which created a greater fall for the water and created more power to drive a wider mill. And in that same year, the railroad went through the town that eventually became Coatesville. It connected Philadelphia with the Susquehanna River 75 miles to the west. That not only provided better transportation for raw materials coming in and finished product going out, but also created a new market for boilerplate. And that market was steam locomotives. They started out really small, but they rapidly grew in size, and as they did, they consumed tremendous amount of boilerplate. And as a result, rolling mills started to pop up all around Coatesville. The Federal Slitting Mill was rebuilt and renamed Rogeby, and in addition to that, in the Lukens Ironworks, other mills started to pop up. Laurel Forge, located down by Mortonville, added a mill in 1825. Samuel Hatfield had a grist mill in Wagontown. He added a rolling mill in 1836. Hibernia Forge added a mill in 1837. Two new establishments were built in 1837 and 1838. And then in 1847, the Thorndale Ironworks was built east of here, and that was the first steam-powered rolling mill. As I mentioned, Laurel Forge was located in Mortonville, and that's where the Buck Run, downstream from the Federal Slitting Mill, runs into the Brandywine. They had a forge that existed before the Revolutionary War, and it said that they actually made cannonballs for the Revolutionary War. And in 1825, they added a water-powered rolling mill. As I mentioned, Samuel Hatfield had a grist mill 3 miles upstream from Coatesville. The grist mill was knocked down around 1962, but in 1836 he added a rolling mill. Hibernia is always known as a forge. It started out as a forge. It was started by Samuel Downing, who bought land in 1793 and 94, built the first forge in 1794. By 1799 he had 2 forges and over 500 acres of land. The Brandywine through this area is very scenic. In addition, it has the greatest fall of any stretch in the local area, which made it ideal to power a mill. It's also located where Birch Run runs into the Brandywine, and there's evidence that they actually added a blast furnace in 1815. I found this 1822 map by Heineman of Chester County, and it shows a furnace located on Birch Run directly above the forge. Charles Brooke purchased Hibernia in 1821. At the time, it had 200 acres. He continued to buy land to provide wood for charcoal until he had over 1,700 acres, and in 1837 he added a rolling mill. The Callan Iron Works was built by Rebecca's mother, Martha, who was Isaac's widow. It's said that it was built for her son George and son-in-law Jesse Coates, but there's little evidence that they ever ran it. It appears that it was leased. The Ironmaster's house is still there today. When you come into Coatesville on 82 from the bypass, that's the large roof that you see sticking above the right-hand side. This is a picture I took from the road down below. There were 3 brothers that married Truman's sisters. There were 2 brothers, James and John Forsyth and John Yearsley, all married Truman's daughters. They built the Triadelphia Ironworks, which in the Quaker tradition meant 3 brothers. And that was located north of the railroad bridge, tucked in on the west side, on land that Truman owned. In 1842, some people from the Pennsylvania Coal and Iron Association sent out surveys based on the census of 1840, and they gathered data on 32 of the rolling mills in Pennsylvania, including the 7 around Coatesville. And one of the things that you'll notice is that they were all remarkably similar. They all had between 10 and 12 men. 5 of them produced 400 tons of boilerplate. The 2 forges, Laurel Forge and Hibernia Forge, also made 300 tons of bar iron, and 2 of them, the Brandywine Ironworks and Laurel Forge, produced nails. Now, some of them had more men associated with the forge operation, but in the rolling mill there was only 10 to 12 men. The Thorndale Ironworks was built a few years later in 1847. James and John Forsyth sold their interest in the Triadelphia Works, went east, contrary to what Horace said, going west, and they built this establishment just east of the railroad station, just west of where the Wendy's is today, between the turnpike and the railroad. Steam power had several advantages. One, you didn't have to depend on moving water. Water freezes in the wintertime, and it freezes first along the edges, which is exactly where the head race would take it off to run the mill. So when the water froze, you couldn't run the mill. When the spring rains came, it made it tough to control the speed because the water was running too fast. It could flood the raceways and damage the water wheels. And the summer droughts created issues where you had no moving water at all. So the mills never ran 12 months a year. They always had issues with their power supply. In 1850, the iron masters met in Philadelphia to discuss things of common interest, mostly tariffs, and they exchanged information. And by 1849, you started to see some difference between the area rolling mills. Several of them, like West Brandywine, Callan, and Triadelphia, added a second mill. So they started to produce more iron. West Brandywine, with 2 mills, produced 1,000 tons of boiler and flue plate. Flue plate was used for chimneys, for the stacks of the furnaces. You'll notice by this time Laurel and Hibernia were no longer making bar iron, they were only making plate. Callan had put in a bar mill, and they were making 600 tons of bar, which was the equivalent of what Laurel and Hibernia had been able to forge. So it was much easier to roll bar than to forge bar, and the forges started to get out of the business. Rebecca retired as an active partner in the business in 1847 and turned the business over to her 2 sons-in-law. The first was Abram Gibbons, who joined the firm in 1842, who had married Martha, and another medical doctor came on the scene, Dr. Charles Houston. He married Isabella and joined the business in 1849. Now, like his wife's father, he was a medical doctor trained in Philadelphia, but got the bug for the iron business, left the medical profession a year after getting married, and in 1853, he again rebuilt the mill. Now, the mills back then were just set on wooden timbers put in the ground, so it was pretty easy to rebuild a mill. It only took a few weeks once you had the material. So he installed a new water wheel, a heavy flywheel, to dampen out the changes in the flow of the stream, which was hard to control. The flywheel was like a gyroscope. Once it got spinning, it continued to spin. So if the water flow dropped down a little bit, the flywheel would take that change out and give you a continuous motion on the rolling mill. He widened the mill to 66 inches and increased the diameter of the rolls to 21 inches. We do have pictures of his mill, but because by that time cameras were around. It had a furnace in one corner, a large flywheel to help out the water wheel, a mill, a platform called a pulpit from where the foreman could oversee the operation and shout instructions. And it's interesting that even today we call the control room of a rolling mill the pulpit. And this mill was driven a little differently. The power was transmitted through the bottom roll across the devices to a pinion gear and then back to run the top roll. The early 2-high plate mills were called pullover mills. Water only flows in one direction, so the rolls could only turn in one direction. Once you took a reduction pass, you had to get the plate back to the other side to take another pass. And to do that, you had to lift the piece up and pass it over the mill. Now the rolls were turning in one direction, so the top was actually turning in the reverse direction, and it would help take it back, but you still had to get the plate up and get it started and catch it on the other side. An artist's picture shows this operation. You have a roller on one side and a helper feeding the plate into the mill. On the back side, you had a catcher and a helper who would catch the plate and pass it back over. And on the top of the mill, you have the first AGC system. Yes, that's Arthur George Cunningham turning the big wheel at the top, setting the distance between the 2 rolls and controlling the reduction on each pass. Lukens built their first steam mill in 1870. They didn't have room in the old building, so they built a new double bay building. The mill was 84 inches wide and had 25-inch diameter rolls. The engine was non-reversing, so they had to get the plate back over the top of the rolls, and by this time the plates were getting wider and heavier. So they had a device called a horse that was like a platform. The mill would roll the plate through and push it up these rolls on this platform. And then this device that you see suspended from the ceiling, from the wooden beams, would lift up the other end of the horse to the top of the roll and would help run it back to the other side where another device would get it, drop it down for the second reduction pass. Furthy and Cope recorded the history of Chester County, and they had pictures drawn of certain things, and one of them was the Lukens Mill. You can see the new double bay building to the right of the center, and the old original mill was converted to a puddle mill. Puddle mills were like a pre-open hearth furnace. It was a furnace that could take iron ore and melt it to pasty consistency, which was then hammered down and the impurities were driven out, and you could get iron. So in 1870, Lukens started to produce some of its own iron for the very first time. Now that iron wasn't considered good enough for boilerplate, but it was good enough for ship plates. And in that time period, the shipbuilders were moving from New York, where the original ironworks started in this country, in New England and New York, down to the Delaware between Chester and Philadelphia. So this became a good business. And at that time, there were several changes going on in the marketplace that really changed the complexion of the iron industry. One was a growing market for steel plates. Bessemer had invented the process of refining iron into steel using high pressure air, and that created a large supply of iron. It had steel. It had higher strength than iron, so people wanted to use that instead of iron. At the same time, people wanted wider plates for boilers because that reduced the number of seams, which reduced fabrication costs, and typically the boilers failed at the seams. So the fewer seams you had, the fewer opportunities for failure. Some mills in the local area weren't strong enough to roll steel, and they weren't wide enough, so they started to fall by the wayside. And then in 1873, we had a recession, which they called a panic, because it was similar to what we had last year when people panicked when their 401s dropped like a rock. And that crippled the weaker mills. As a result, they started to drop out. Hibernia and West Brandywine were abandoned between 1878 and 1880. Rogeby had struggled to get through the Civil War even though demand was very high. It was offered for sale in the spring of 1865, and before it could be sold, it caught on fire and burned. The site was eventually converted into a paper mill. The Callan rolling mill became known as Valley when Valley Township was formed, and it was eventually bought by the Pennicks. It had 4 rolling mills by 1876, and one was 110 inches wide and considered to be the widest mill in the country. It had a capacity of 7,000 tons a year with the 4 rolling mills. Valley was located where Old 82 cuts off of the 4-lane New 82 on your way into Coatesville. As soon as you cut off onto the old road, the flat spot along the Brandywine is where the mill is located. You can still see the trestles where the railroad branched off from the Wilmington and Northern and went across to the site. And if you look closely, you can still see where the tail race came out of the mill and emptied back into the Brandywine. The Viaduct Mill, located just north of the railroad bridge, continued to grow. It added mill after mill powered by steam. It eventually had 4 mills, and it increased its capacity and its employment. Dr. Houston partnered with a cousin named Charles Penrose, and together they ran the operation from 1859 to 1881 when Penrose died. His 2 sons went off to college, Abram and Charles Lukens. They joined the firm in 1872 and 1875, and the name was changed to Charles Houston and Sons in 1881. And then interesting things started to happen. Before this, Lukens was again unremarkable in the local scheme of things. The Viaduct Mill with their 4 mills could produce 11,000 tons a year. The Pennock mills, the Valley mills, had 4 rolling mills, and they could produce 7,000 tons a year. Lukens had 2 mills, and they could produce 6,000, and Thorndale was still hanging on but struggling, and they could produce 4,000 tons a year. Lukens started to roll steel slabs into plates, and they experienced a lot of issues with broken rolls. Steel was a lot stronger, and the old mills couldn't hold up to it. So in 1880, they added a 3-high finishing mill. It was operated by the same steam engine that ran the 2-high, so you could only run one mill at a time. The slabs were heated in a furnace, broken down on a 2-high mill, and then transferred over to the 3-high. 3-high was much faster, so it finished the plates faster, much hotter, and they didn't break the rolls. It also was a stiffer mill, so it gave better gauge performance. Now, the 3-high mill was actually invented by John Fritz, who was born about 4 miles south of here. In 1857, he was working at a Johnstown rail mill, and he had problems with rails getting cold, only being rolled in one direction. So he realized if you could turn the middle roll in just one direction, but had a roll on top and bottom, in one direction you could roll between the middle roll and the bottom roll, and then the tables lifted the piece up and you came back between the middle roll and the top roll, and that way you didn't have to just pass it over, you took a reduction. You finished much quicker, the material stayed hotter, and you didn't have the cracking problems. This is what the original mill looked like in the mid-1880s before it was knocked down. The structures looked like a large barn. They had wooden beams inside, so you could move very big pieces around because cranes were just cantilevered over a beam. And about that time, a worthy competitor emerged. Two brothers named John Sharples Worth and William Penn Worth built the Brandywine rolling mills just south of Lukens Mill. Their father, Shesbazar Worth, was the partner of U Steel, and they owned the Viaduct Mill and the Laurel Mill. So they grew up in the business. When their father died, they stayed in the business a few years, sold their interest, and went down to the area that became South Coatesville and built a 90-inch wide 2-high mill that had 28-inch diameter rolls, and in 1882 they started up. And right between the two plants, a company called Coatesville Boiler Works started, and they consumed vast quantities of plate. This is from a booklet they put out around 1910 that said they are located between and adjoining two of the largest plate mills in the country, the Lukens Ironworks on the north and Worth Brothers on the south. They shipped products by rail. These buildings eventually became plants 4 and 5, or flame cutting area, and the Wilmington and Northern crossed right in front of their buildings. They made a variety of products: kilns, ladles for the iron and steel industry, and storage tanks for the agricultural industry. And of course their main products was boiler, hence the name Coatesville Boiler Works. This boiler looks like it was built out of plates about 6 foot wide, so the boiler is about 18 foot wide, and it took 3 plates, which resulted in 2 rows of rivets to connect the plates together. If 10-foot plates had been available, that could have been built out of 2 plates instead of 3, eliminating a complete row of rivets. In response to that, in 1890, Lukens built a 10-foot wide plate mill. It was a 3-high mill with 34-inch diameter rolls designed by Birdsboro just for boiler plates. It was steam-driven, and it started up on the exact day of the 80th anniversary of the company's founding. It had tables to take the pieces to the mill and away, and suddenly they had a capacity of 40,000 tons a year and jumped from only supplying 20% of the local market to 50%. This is a picture of the mill buildings taken around 1890. The big one on the right, number 3, is a 120-inch mill. Number 1 is the old original mill, and number 2 is the 84-inch mill. And that spelled doom for some more of the local mills. Laurel had been bought by the Worth brothers out of sentimental considerations. They went back and bought it, tried to make a go of it, but they couldn't do it. They also bought the Viaduct Mill, but Laurel fell by the wayside in 1892. The Thorndale Ironworks was bought by a family called the Baileys. Now, Joseph Bailey, the father, was a brother-in-law of Rebecca Lukens and actually helped her run the business the first 3 years after her husband died. Joseph had 6 sons. one of which was a medical doctor, and all 6 of which got into the iron business. They owned big mills in Harrisburg and Pottstown, but 2 of the brothers ran the Thorndale Ironworks. They ran until 1893, and then they couldn't keep up with the other mills, so they shut it down. They also owned 1,200 acres around Thorndale, which became known as the Ingleside. Meanwhile, back in Coatesville, a race was going strong for the widest plate mill in the country. The Worth brothers built a 132-inch wide 3-high mill in 1896. It had 36-inch diameter rolls and could roll 40,000 tons a year. The Valley Ironworks had been bought by William Kurtz in 1888, and it was rebuilt. So by 1898, Lukens started to lead the pack. The Brandywine Mill, run by the Worth brothers, was close behind, and the Viaduct and Valley started to fall further behind. In response to what the Worth brothers did with their 132-inch mill, in 1900, Lukens took the 120 mill out to 134 inches and changed the rolls from 34-inch diameter to 36-inch diameter to make them stiffer. They added cooling beds and tables and increased the capacity to 90,000 tons a year. And by doing that, they reclaimed the title of the largest plate mill in the country. 3 years later, they built an even wider mill, a 140-inch mill that had 38-inch diameter rolls. It started up on June 2nd and was powered by a 2,200 horsepower steam engine. It was designed to handle wide plates from beginning to end without any manual intervention, and because of that, it could produce 200,000 tons a year. Now, before that, once the plate was rolled, it was set on the ground. It tended to make it go out of flat. Then it was picked up again in a separate operation, taken to a stationary shear, and a crew of men had to move the plate around on casters and cut all 4 sides of the plate. But in 1903, Lukens put in this mill that not only had a leveler, but had a cooling bed that had over 11,000 square feet of cooling space. It also had hydraulic lifts to raise the plate up so they could inspect the bottoms of the plates. And at the end of the run, at the end of the cooling bed, it moved through a 12-foot shear that cut the plates to length. So the other 2 shears were used to cut the sides of the plate. So it eliminated cutting the length of the plate by hand. Now the Worth brothers were building another mill at the exact same time. It started up 2 months after the 140 mill, and it was 152 inches wide. So 2 months after Lukens started up the widest mill in the country, the Worth brothers reclaimed the title, which they used in their advertising. 152-inch roll train, the largest in America. Other companies around the world were building larger mills. Davy had built several 160-inch wide 2-high mills in England, and the Vitkovich Works in Austria built a massive 178-inch wide mill in 1910. It had 49-inch diameter rolls, and it was the widest mill in the world. You can see the chunk of steel on the table rolls and the man standing to the left of it that gives you some perspective of how large the mill was. In that same year, Lukens celebrated its 100th anniversary, and the competitors for the widest mill in this country declared a truce and came together to set a marker and a plaque which was in front of the old chemical lab. So members of the Houston family and the Worth brothers both participated in the ceremony. And then in 1918, Lukens hit the home run by building the widest mill in the world. It was 204 inches wide. It was the first 4-high plate mill ever built. Started up in May of that year. Now Mesta, who became a major mill builder, was building steam engines back then and supplied a 20,000 horsepower engine to run that mill. They couldn't get rolls big enough to make a 2- or 3-high mill. The rolls were iron chilled. The biggest roll they could get at that length was 34 inches, so they used two 50-inch cast steel rolls as backup rolls to prevent the deflection, and this mill also had the capacity of 200,000 tons a year. The 4-high mill was a new design developed jointly by Lukens Engineers and United Foundry. It had smaller diameter rolls that were supported by larger backup rolls to prevent deflection. And the rolls reversed in both directions, so it rolled the plates very fast before they could get cold. Legend has it that Charles Lukens Houston was tired of playing leapfrog with the Worth brothers, so he called his engineers into his office and told them, "Go out and measure a rail car and you tell me what the widest plate is that can be shipped." Supposedly they came back and said, with special blocking, we can ship 204 inches. So they built a mill that was 204 inches wide. It received a lot of attention because it was a monstrosity. They had to overcome a lot of engineering obstacles to build the mill. In 1919, it was widened to 206 inches, and for decades it was recognized as the widest mill in the world. Growing up in Coatesville, I remember the neon signs on the north end of the Open Hearth number 3 declaring that it was the widest mill in the world. I also remember all the trucks had the L logo on, and underneath it said world's largest plate mill. A mill that wide enabled Lukens customers to build very unique products. This is a firebox built by the Baldwin Locomotive Works that was built out of one plate of steel, 195.5 inches wide. Such unique products were used in Lukens advertising, and it showed up in an advertisement for Lukens. But the Worth brothers didn't give up easily. They continued to grow. They built 3 blast furnaces in South Coatesville. They had a lot of open hearts. They even owned a hotel in South Coatesville, which eventually became the Midville Apartments. By 1915, Lukens was still in the lead with a capacity of 380,000 tons a year with 4 mills. Worth brothers also had 4 mills and could produce 300,000 tons a year. But the Worth brothers owned both Viaduct and Valley, and together they produced 55,000, so they were just a little bit behind Lukens, but Lukens was producing more than half of the plates rolled in the Coatesville area. In 1919, they finally gave up on the Valley Ironworks. It was dismantled. But Lukens continued to expand. This picture was taken around 1920, and they had expanded to the other side of the Brandywine. They had a Universal Mill, the 140 Mill, and the 206 Mill on the west side of the Brandywine. In a book they put out in 1924, they described some of their history and also labeled all the buildings so we can go back and look at them and see what they had and where they were located. And then the 5th generation of the family took over. Abram Houston served as president until 1925, and when he died in 1930, he was still serving as chairman of the company. His son-in-law, Robert Walcott, became president after him in 1925 and served in that capacity until 1949, and then served as chairman of the board until 1957. One of the first things he did was build a new 84-inch wide tandem mill. A tandem mill, as opposed to a train being run by the same engine connected by couplings, were 2 mills in series instead of parallel. It was built by United, the same company that built the 206 mill. It had a 2-high roughing mill with 34-inch diameter rolls and a 4-high finishing stand. The finishing mill had 23-inch work rolls and 40-inch backups, and this was only the second 4-high mill built in this country. With it, they could roll plates down as thin as 1/8 of an inch and as wide as 72 inches. And it's interesting because this became the prototype for the hot strip mill, where they added finishing stands and were able to roll thinner and thinner plates and eventually coil them. It had a very efficient mill layout and was designed to take slabs from the heating furnaces and not touch them again until they were in a shipping area ready to ship. It had a lot of unique features. It had the very first differential screw down to level the mill. It had an automatic roll change rig in 1927. It was the first mill built with roller bearings instead of bronze bearings. And it had the very first rotary side trimming shear in this country. So they could cut the ends, cut the sides, level the plate, mark it, stamp it, and deliver it to the shipping bay ready to go. It enabled them to provide very light plates to their customers, plates that today are provided by hot strip mills. In 1935, Lukens celebrated its 125th anniversary, and the leading technical journal of the day, the Iron Age, dedicated an entire volume to entire issue to the celebration, described its history and products, and again provides us with a lot of insight as to how the company was developing at that time. By 1935, Bethlehem owned the works that had been the Worth brothers. The plate mills were shut down during the Depression. The large 152-inch wide mill was moved down to Sparrows Point and eventually became the breakdown mill for their 160-inch finishing stand. Lukens had a capacity of 416,000 tons a year. The Viaduct Mill was still operating, producing charcoal iron for boiler tubes, and it had a capacity of 30,000 tons a year of tubes. That's a picture of the tube mill that the Worth brothers built in 1903. And my grandfather came to Coatesville in 1916 and worked in that mill until it shut down around 1942, and then came over to Lukens and finished out his career. These are buildings that eventually became the G.O. Carlson's plant, which were just knocked down a few years ago. World War II broke out and created a large demand for wide, thin-gauge plates for shipbuilding. So the government contracted United to build another plate mill in Coatesville. It was 120 inches wide, and they took the old 3-high mill, which after being expanded to 134 inches was cut back to 112, and they built the mill around that 3-high mill, and that served as a breakdown mill. That made the 84-inch mill obsolete, and the tandem mill was shut down right after the war. By 1947, Lukens had expanded considerably. It had buildings on both sides of Strode Avenue and both sides of the Brandywine. The north side, starting from the Main Street, Route 30, had the rolling mills, the steel making, number 2 and number 3 open hearth shop, the flanging buildings, and the flame cutting. Now the flame cutting you might recognize as the old Coatesville Boiler Works. They added offices in the front of the buildings, and that became the flame cut division. On the west side they had batch heat treating, descaling, and the clad shearing and forming operations. And Lukenweld, which was included Lukenweld number 1, which was the old machine shop for Worth brothers, and another plant that the Navy built during the war were the 2 weld shops. Lukens had the first commercial weld shop in the United States. Also in the 5th generation were the children of Charles Lukens Houston. C.L. Houston served as first vice president until he was 91 years old in 1951, with over 75 years of company service. His son, C.L. Houston Jr., succeeded Robert Walcott as president in 1949, and his brother Stuart Houston succeeded the father as first vice president. So it was run by 5 generations of family members. The Korean War broke out in the mid-50s and created a large demand for armor plate. Rolling armor plate on a 2/6 mill consumed too much time breaking down ingots into slabs to get them to plate, and the 140 wasn't powerful enough or couldn't handle the heavy weights of the ingots, so Lukens needed a new slabbing mill. In 1959, Mesta built a tremendously powerful mill. At the time, it was the most powerful mill in North America. It was designed to break down ingots and supply them to the 2/6 mill, but it also had the capacity to finish heavy gauge plates right on the mill. It also included a very powerful edging mill that could squeeze back the camber on the sides of the ingots and make the sides very square. They soon realized that this mill was very powerful and very stiff, so in 1967 they extended the mill buildings and created a finishing mill by adding shears, cooling beds, and a leveler. And today this is the main operating mill for the Coatesville plant. It's the workhorse. But that old 2-6 mill is still operating at age 92. It produces very wide plates that no one else in this country can produce. It's only used 8 to 12 hours per week, but it's a very special application and we can't do without it. The 120 mill, built in 1942 by the Navy, also was resurrected in 1994 after being shut down since 1985. Those mill housings were taken out and transformed into the Steckel Mill at Conshohocken. But that 112 mill that was built in 1890, it started out its life as a 120-inch mill, is waiting to hear its fate. Last year the buildings were knocked down around it, and now it sits out in the environment wondering what's going to become of it. So, in summary, it's been 2 centuries since the head race was first opened at the Brandywine Ironworks and Nail Factory, and the power of the Brandywine turned the water wheel that rolled the first iron in this area. Water power was eventually replaced by steam and again replaced by electricity as rolling mills grew both in size and in complexity. Only one mill survived through periods of war and peace, panic and prosperity, expansion and innovation. There were many innovations that were started first, introduced in the mills of Coatesville. They rolled the first boiler plate in America, the largest plates in the country, and then the largest plates in the world. The first 4-high mill and the second 4-high plate mill were here in Coatesville. And we also saw innovations like the first differential screw down, the first roller bearings, the first rotary side shears, and lots of other innovations, all started right here in this area. So I thank you for your attention, and I would love to answer any questions that you may have.
Good job.
Thank you. Oh, come on, Skip. You probably say that to all the speakers.
No, this is very special.
Did they ever use water turbines?
Not that I can see. I've seen a lot of the other places use turbines, but water wheel until they went to steam.
When you refer to a powerful mill, the power is the power of the engine that powers it? Is that what you're referring to?
The torque that the engine can put out to drive the piece through the rolls and take the reduction to reduce the iron or steel to a thinner gauge.
What's normally the amount of reduction on each pass?
Depends on the grade and the width. Today, if we're breaking down an ingot, we could take an inch, inch and a half draft in one pass. The roughing mill at Conshohocken was repowered in the late 1990s. It has 16,000 horsepower, and on a 100-inch wide carbon slab, it can take an inch and a half reduction. Before that, it could only take a 1.1-inch reduction when it had 8,000 horsepower. But when it gets down close to gauge, you may only be taking 10,000s or 20,000s of gauge off.
Rich?
Yes?
How do you think they maintained enough heat in those plates in the early days to continue the roll before they had to actually put them back in or reheat them or do something?
Iron was very soft, so it didn't take much heat to get it soft enough to roll it. And they started out, again, just like we do today, we vary the starting thickness depending on the final thickness.
Right.
So they may have started with a 3/4 inch thick forged bar to roll the thinnest gauges, and they may have only had to take 4 or 5 passes. The information that I have on this mill in Massachusetts said that they could take 1/4 inch reductions on each pass, because again, the bar is only 3 to 5 inches wide, so it could go from 3/4 of an inch down to 1/4 inch in 3 or 4 passes.
Which was how much time do you think it was about?
About 5 minutes.
Okay.
It had to go through. They were only about 4 foot long, 8 foot long when they finished. They'd go through, pick it up, hand it to the roller, take it through again. So it didn't take much time at all. It was a big difference rolling bar and rolling plate.
Yeah.
When they built the 84-inch mill, now suddenly you had very wide pieces, and they had to come up with a better idea to pass these pieces back over the top. And it's interesting, I actually found a book written by the British iron and steel industry in 1903. They sent a team of people over to this country to study the American iron and steel industry. They had a team for the melting areas, a team for the rolling areas, a team for the finishing areas. They had a team dedicated just to plate mills. They spent a lot of time in Coatesville. The section on plate had about 5 pages on Lukens mills, a half a page on Worth Brothers, and a page or 2 on the South Works of U.S. Steel in Chicago and a couple of the other plate mills. But they focused on Lukens.
Just one more question.
I'm having a special today. You can ask all the questions you want.
Yeah, as they developed these mills, especially I think the 3 high so on, how did they keep it from cambering? In other words, you had pressure on the edges. You really didn't have too much on the center until you had maybe the 4 high.
I do not know, because they did not have any way of leveling the mill. Apparently you had to have it straight from the beginning. Now I don't know if they had a way to cut something off the roll, if it continued to do that to level the mill, but they didn't have differential screws to do that. Now what they might have done was just put a bias in the roll, in the screw, and turn down one side more than the other, and just by trial and error adjust the screws from side to side until they got a level plate.
I was trying to explain to what the camera means is you had it thicker in the center and it tailed off towards the edges, so you didn't have a continuous thickness all the way through.
If you bored down too hard on one side, you made that side longer. That side had to go someplace, so it hooked to the opposite side. Same thing happens on a belt sander. If you push down with a piece of wood too hard on one side, the belt starts to walk off the rollers. Yes?
Was the Worth Brothers, did they shut down? Was that just because of depression, or did they?
Worth Brothers sold out to Midville in 1915 for $11 million. The group of guys who quit U.S. Steel over a fight of how to control the company. Should they have centralized control or individual plant control? A fight that goes on in corporations today. So 3 guys broke away, bought up a couple steel mills, and suddenly they were the 3rd biggest steel company in the United States behind U.S. Steel in Bethlehem. The Worth brothers took their $11 million and went down to Claymont and started Worth Steel, which is still operating today as Claymont Steel. Midville sold out to Bethlehem in 1923. And during the Depression, the iron making and steel making and rolling mills were shut down because of the Depression. They moved some of the equipment down to Sparrows Point, but the buildings that became Carlson's continued to operate until the early 40s. Any other questions?
Did you say what year the Thorndale Ironworks started?
1847.
What did they use for power? Steam?
Steam. That was the first steam mill in this area. All the other ones were water. That was the first rolling mill built away from the Brandywine or one of its tributaries.
This is the west branch.
Yes. And surprisingly, there were no rolling mills on the East Branch.
No,
There were a
that's
couple
right.
forges. Yes, Scott?
Yeah. How long have you been working on this research, and where did you get your research from?
Been working on it for 3 years. I have over 200 resources from books. A lot of information came from this book, American Iron. Actually, this book has a map in it from 1858 that showed that picture with the 8 rolling mills in Coatesville. And I had no idea that there were 8 rolling mills in Coatesville. And it took me almost a year just to identify the 8 rolling mills. Google has put a lot of books on the internet, and I found a lot of information in books from the 1860s, 1880s. They also have a lot of journals on Google, including the Journal of the Franklin Institute, which appeared to have been the leading technical journal in the 1860s, 70s, and 80s. And little by little, I was able to piece all this information together and start to understand, okay, they did this, and then they did this, and this is what made this work. But it hasn't been easy because there's no clear source that you can go to and explain exactly how these things were done.
Any other questions?
Yes, another question.
I just want to, the Thorndale Mill, is there anything left of it?
No. Stuart Houston recorded a lot of historical information, and he wrote a book called Rambles, where he took 8 excursions starting at the Coach and 4 Inn and taking different routes. And he mentions that, I guess that was in the 1830s, there was still a house that was either, there was part of the Ironworks. It was still there, but it was in bad shape. I believe the Forsyth brothers sold out their interest in 1847 and went down, bought 16 acres and built tenant houses and an ironmaster's house. And I think those houses are on Hazelwood, which is the south side of the tracks. There's some old houses through there that are just opposite about the exact location where the mill should have been. But other than that, there's no remnants between 30 and, now actually the railroad was 2 tracks wide, 1 track and then 2 tracks, and expanded to 4 tracks. So they had to level that, and it's a higher elevation than the road, and I think it might have covered up part of it. But I have old newspaper clippings. Al Brown has helped me a lot with the research. He goes to the, Al, stand up. Show him who you are. Yeah, Al. He goes to the Historical Society and digs through old newspaper articles and lets me read them. And they dismantled the Thorndale Ironworks in 1903. And after that, it just fell into disrepair, and eventually something else was built on that site. But again, these mills were about the size of a barn, so they weren't very big. So it didn't take much to reduce them to rubble. It was more the Worth brothers who really expanded, and Lukens that built what we think of today as steel mills with very large buildings. But even if you go to Hibernia, you don't hear about rolling mills. You hear about Hibernia Forge. Or Hatfield, I was amazed. You heard about the grist mill. It was not knocked down until 1962, and it had a lot of press in the paper at the time, but didn't mention a rolling mill at all. Yeah, I'm not getting any questions from the front here. You're not holding up your end. Did you sleep through the entire presentation?
Just most of it.
Okay, an honest man. Yes.
Which wasn't Horace Beale in Thorndale first, but did he start
Not
the
first.
Forsyth?
Forsyth started it, sold it out to someone, and the other thing is when you go through this history, a lot of these places were in receivership every other year.
Oh, yeah.
And they were just sold out. Apparently, if Gene supplied forged bars to me and I didn't pay him, he would go to the sheriff and say, hey, Rich owes me money. The sheriff would come and say, okay, pay him or I'm going to put the place up for sale. So they were sold, and sometimes it looked like the people said, the sale's tomorrow, okay, here's your money, and avoided the sale. And sometimes they were sold out from under the people. Now, Horace ran it for about 13 years. He started out as a clerk at Laurel, and then went to Pottstown, and then came, not Potts, Phoenixville, and then came to Thorndale and ran it. Then he went up to Hibernia.
At least the Hibernia property, yes. That's
And
right.
he ran Hibernia, and then he tried to buy it after Brooke died. And the daughter said, yeah, it's not enough money. So the repair shops of the Pennsylvania Railroad were in Parksburg. And then eventually, when a railroad was extended out to Pittsburgh, they moved it to halfway point, which was Altoona. So they had these big, not big, but relatively large buildings empty. So he went and struck a deal with them, and the next day, Brooks' daughter said, "Oh, I changed my mind, I'll take your deal." And he said, "I'm sorry, I just made another deal." Hibernia folded. Parksburg Iron Company for 50 years was extremely successful.
Right. Yeah, Hibernia Mansion, I think, has a portrait of Horace Field. He came from one of the family because of his involvement with the property, but he never owned it, to my knowledge.
No, he ran it. He was the, I guess you would call it the superintendent, the works manager. And when Brooke died, he tried to buy it, and she wouldn't sell at the price he was offering. Any other questions? Going once.
Hey, Rich.
Yes.
How about the rolls for the mill? Where'd they get the rolls from?
There were companies in Pittsburgh that supplied them. United and Mesta. This 1935 book has advertisements for the rolls. Back in the 1800s, I don't know. There was a company in Norristown called Newbolt that supplied housings and machinery, and they might have supplied rolls. They started out in Philadelphia as a foundry and probably supplied rolls. But the rolls came from a foundry. Question I have is, how did they get a mill housing from the foundry to, say, Coatesville in the 1840s or 1850s? Had to be by wagon. There was no railroads. Big wagon like a Conestoga wagon, and move it and erect it all with ropes and pulleys.
Conestoga wagon only picked 3,500 pounds.
So they must have had specially built, or else the housings didn't weigh more than 3,500.
They had Lukens steel around their wagon wheels.
Iron. But those wooden shafts probably did hold up.
Very good. And the source of the iron in the early days was probably all the furnaces that were in the air, like
There were-
Joanna, Hopewell.
Joanna, Hopewell. Some of the information says that they actually went west for the forge bars. In Carlisle and Lancaster County, I don't know why they didn't use like Downing Forge or Springton Forge, local forges.
Yeah.
There were forges in Chester County, but Julian Skaggs' works from 1975, where he looked at 1850 to 1870, he mentioned names, and I went back and traced those names, and they were all Lancaster County and Carlisle. Any other questions? Thank you for coming. Thank you for your attention.
Yeah, I want to thank you for coming and giving this lecture. I guess a couple of key points is, you know, it probably gets some barrels and a wagon around here. That might be a good product to have. And if it's just a simple barn, that probably won't be too much to reconstruct. And no, but I think really the research that you've done and how you present the material is very clear, very concise. So I really want to thank you again for coming and doing this for us. So thank you.
My pleasure.
Thank you very much. A couple things. Our next lecture is Paul Paskoff, who you know, he has big shoes to fill. Paul Paskoff, out of Louisiana State, professor who has done research on Lukens. He's going to be coming up and talking about the global economy as this company has, and the markets evolved, and it was not necessarily just a town company. I think it was regional. Rebecca had selling agents in the globalization of the steel market and what that means today. So that should be very interesting. That's June 3rd. Here, it may also be up at the Art Building. And then the big anniversary events, we just have to plug those. June 26th, we have an event here, which is Saturday, and we'll be covering the history of Lukens and a marker dedication. July 2nd, we'll be doing, that's a Friday, the actual date of the anniversary, we're doing a tree planting. ArcelorMittal is having a reunion type event on July 5th, and then of course the ice cream festival and fireworks is July 10th. I want to thank ArcelorMittal, Houston Foundation, Coastal Savings Bank, and of course the people who come to our lectures and support our organization. but I think tonight's topic is just fascinating. It's the heart of what it's about. So again, thank you, Rich.
You're quite welcome.
Okay, enjoy. Thanks again. Okay, thanks again. Have a good night.
It's a lot of work, but